the rules for exponents rarely occur alone. They usually occur in combination. And so we need to look at problems in which more than one rule is operating at the same time. We need to look at problems in which the rules apply more than once in the context of the problem itself. So let's look at some of those now. If we have 5x squared minus 2x to the sixth, we realize if we look that there's nothing but multiplication there, and so the parentheses really are just confusing the issue. This whole problem could be written as 5x squared times negative 2x to the sixth. And when we use properties of numbers and allow us to use the commutative property here, this problem could turn into 5 times negative 2 times x squared times x to the sixth. Now, having done that, we realize that 5 times negative 2 is negative 10. And these are product of powers. When we're multiplying powers with the same base, we can keep this base and add the exponents. 2 plus 6 is 8. And so we've rearranged. You don't have to write the in-between steps. If you see what's going on, you can go directly to the answer, but you're still using the multiplying property of exponents and adding them together. Now let's look at this next problem. This next problem is a fraction of 54b squared c to the fifth divided by 6b to the fifth c to the third. In this case, we want to use the quotient rule, but what we really have here is three separate problems. We have that division problem, 54 divided by 6. Those aren't exponents, they're just coefficients. 54 divided by 6 is 9. Well, then we have a second problem involving these powers of b. Now, when we have powers of b and we're dividing by powers, when we're dividing like powers, we're going to subtract the exponents. So this becomes b to the 2 minus 5 power. We'll do that calculation in a second. Finally, we have the c terms. The c factors here are, well, they're quotients as well, so we're going to take that c and use it as our base, and then we're going to subtract these exponents. 5 minus 3 power. Well, when we do that, we'll end up with our final answer is 9 b to the negative third c to the second. Do you see anything that you might want to change before you finish call it your last answer? How about that b to the negative third? That would remind us to make this a reciprocal, and so we would get 9c squared over b cubed. Okay? Now let's look at this last problem. Once again, we have the same thing. We're going to look at the coefficients alone. We'll look at the x's alone. We'll look at the y's alone, and even the z's alone, and we'll see just what we have to do. If we take 3 and divide it by 12, 3/12 reduces to 1/4. Then we look at the x's. We have x to the 6 minus 0 power. X to the 6 minus 0 power is just x to the 6. Then we look at the y. Y is to the 7 minus 5 power. 7 minus 5 is 2. Finally, we'll look at the z. Z, what power is that? Oh, 1. Okay. Z to the first divided by z to the fourth is z to the 1 minus 4 power. Well, 1 minus 4 is negative 3. If it's a negative power, we want to put it into the denominator. So this answer would be x to the 6th y squared over 4z. This was 1 minus 4 is negative 3. Move it down, positive 3. So the answer is x to the 6th, y squared over 4z cubed. This is combining some of the properties that we've already done and seeing that a rather large, complicated-looking problem can sometimes be broken down into several small problems where you just use one of the rules several times. Just remember that coefficients are not exponents. They're just fractions, and they simplify like any other fraction. It's the powers and exponents that you apply the rules for. Say the rules as you do every single problem, and you'll be much better off and make fewer mistakes.